A proton accelerated by a potential difference of 500 kilovolt flies through a uniform transverse magnetic field with induction of 0.51 Tesla. So B is equal to 0.51 Tesla. The field occupies a region of space D equal to 10 centimeter already marked in thickness. Find the angle through which the proton deviates from the initial direction of its motion. Okay. So how much it will deviate? That means you have to find out theta. Now, as soon as the charge particle enters into the magnetic field, now it was moving along the direction of positive x-axis. The magnetic field makes it to move in the circular path. It doesn't change the speed. Speed remains the same. It only deviates the direction. So by the time it reaches here, if the magnetic field gets finished, then it moves in a straight line. But compared to the original direction, which is along x-axis, it has turned through an angle theta. That is what you have to find out. Okay. Now, as soon as the this proton enters into the magnetic field, it starts moving in a curved path. That means circular path. Now, if I redraw it like this, and if this is the space where the magnetic field is present, and if this is D, and as soon as the charged particle is here, now it starts moving in a circular path. And if this, I'll change the color. Okay, right. And if this is the curved path like this, then its center will be somewhere here. So this will be the radius, first radius here, R, and the same radius will occur somewhere here. Now, and from here onward, if there is no magnetic field, then it will move straight. And this was the original direction. That's what we have to find out, theta. Now, if you observe this, you can say this is the horizontal position. This is the next horizontal position. Then this is also D. This is R. This is R. So from here to here is also R. This is the curved path like this. I want to shift this theta. Now, for the angle between this tangential direction here to the curved path, of course, this curvature will continue like this. Angle between the tangent and this horizontal is theta here now. Now, for this horizontal direction, for this one, this is the perpendicular. This line is the perpendicular. So this line is perpendicular to this one. And for this tangential direction, this is the perpendicular. So these two lines make an angle of theta. And if you draw two perpendicular lines to this and this, they should also make an angle theta. For this line, this is perpendicular. So here, for this tangent, the radial vector is perpendicular. So these two perpendiculars should also make an angle theta here. So that is also theta. So if this is theta, then this is also theta. Now, if you take sine theta here, what you will get is sine theta is equal to opposite side D divided by radius R. Now, how to find out? And D is known. And if you know what is the radius of the circular path, of course, the job is over. And we know the formula for radius of the circular path, that is mv by qb. So R is equal to mv by qb. We know this one. So substitute it here. So what is sine theta? Sine theta is equal to d qb t by mv qb. So substitute for this, you will get the answer. Because everything is given, that implies sine theta is equal to distance 10 centimeters, that is the 0.1 into Q, it is a proton, so 1.6 into 10 to the power minus 19. And magnetic field, it is it is accelerated through a potential difference. So we have to remove velocity also. Velocity is square root of 2qv by m. That has to be substituted again. Okay. So because you know half m square must be equal to kinetic energy is the potential energy due to magnetic field, electric field. Then v is equal to square root of 2qv by m. So that has to be put here. Okay, so finally, what will be the answer? That implies sine theta is equal to dqb d, 1 minute. Yes, dqb by m velocity root of 2qv by root of m. Now we can minimize this. db will remain there only. db into root of, you can take this q here, q square m. You can take this m here, 2qv m square. I have taken this m as m square and this q as q square, square root of q square. So what is sine theta? Sine theta is equal to db into root of, so one q will get cancelled, one m will get cancelled. So q by root 2v m, q by 2mv. Yes, that is sine theta. So just substitute the values. Sine theta is equal to d, 10 centimeters, so 0.1 meters. B, strength of magnetic field was 0.51 Tesla. Yes, 0.51 Tesla. Root of Q, 1.6 into 10 to the power minus 19 by 2. V, the accelerating potential difference is 500 kilovolt. 500 kilovolt. And m is mass of the proton. You can take it as almost 1.66 actually. Minus 10 to the power minus 10 to the power minus 27. 1.6 I'll take, because I want an approximate answer. So for this one, the answer is sine theta in equal to 0.1 into 0.51 into square root of, cancel this for the time being. This will be 1000, and this 1000 and this 10 to the power 3, 10 to the power 6 again. 10 to the power 6 minus 27, 10 to the power minus 21. 10 to the power minus 21 in the denominator and 10 to the power minus 19 in the numerator. Finally, this will become 10 to the power plus 2, because plus 21, this one goes to the numerator, plus 21 minus 19. Plus 2, root is 10 to the power 1, that means into 10. Into 10, 0.1 will become 1. So sine theta, 0.1, 0.51 into 10. That implies sine theta is almost equal to 0.51. That is equal to, sine theta is pi by, it's 30 degrees, because sine inverse of 0.51 is sine inverse of half. Sine 30, pi by 6. They are asking only that what is the angle. So theta is equal to 30 degrees, because sine theta is half. That is the answer. Thank you.